Okay, so here we have a problem where we have to use our knowledge of similar solids. So basically we have, okay, let's read it. Miss Greco recently perfected her recipe for tomato sauce. She will be making more tomato sauce, but her current pot is too small. So this pot is too small. She's planning to replace it with a larger pot. Both pots are in the shape of a cylinder, but they don't mention that the two cylinders are similar. So we're going to assume that they're similar. The area of the base of the current one is 208 and its height is 20. The area of the base of the bigger one is 468 centimeters squared, and we don't know its height. Okay. And Miss Greco stores her tomato sauce in jars that hold 640 mLs. How many more jars? Okay, so we have to figure out the volume of this. Okay, so we have to figure out the volume of this, but we don't know the height. If I look at this, I have an area of the small one and I have an area of the bigger one. So since I have the two areas, I can find a ratio of areas. So what I'm going to do is take the area of the big one, divided by the area of the small one, and that will give me 468 divided by 208 centimeters squared, which gives me 2.25, and that's the 2D ratio. I took the big area divided by the small area of the base, and that gave me 2.25. And if I look at 2.25, that's a nice number. How do I go from the 2D ratio to the 1D ratio? So what do? Take the square root. Take the square root, and that's nice because 2.25, well, that's a nice perfect square. I can take the square root of 2.2 of the 2D ratio. So take the square root of the 2D ratio, and that will give me the 1D ratio. So the square root of 2.25 is 1.5. So that's the 1D ratio. Now, how am I going to find the big height? Well, since I know the 1D ratio, if I want to go from the small height to get the big height, I would have to use the 1D ratio because that's one-dimensional measurement. If I wanted to go from the area, small area to big area, I will have to multiply by 2.25. So let's find the big height like this. So the small height is that. What do I multiply by? Well, the 1D ratio, multiply by the 1D ratio. So the big height is going to be 20 times 1.5 is 30. So now I know that the big height is 30. Okay, so now I can find the volume of the big one. I have the area of the base and the height. So if you remember, the volume of a cylinder is just area of the base times the height. So the area of the base times the height will give me the volume of the big one. So I know the base, I know the height, just multiply it out. 468 times 30 centimeters squared times centimeters is centimeters cubed. So it's 14,040 centimeters cubed. Remember that centimeters cubed is equivalent to milliliters. So I can just change this to milliliters. And let's find, so how many jars can I make with this? So just divide that by 640. They're both in mLs. So I can make about 22 jars approximately. And let's find the volume of the small one. So we have the base, the area of the base, we have the height, just multiply. So same thing, area of the base times the height, 208 times 20, that gives us 4160 centimeters cubed. I can just change that directly to milliliters. There, 4160 milliliters. How many jars can I make with this? So mLs divided by mLs, 6.5 jars. And then I just subtract 21 minus 6.5, which is approximately 15.43 jars. And that's it. So I could have found the volume. I could find the volume of this and then multiply the volume by the 3D ratio to get the big volume. You can try doing that. So find the volume of this. Well, we know the volume. And multiply by the 3D ratio. So I can multiply, the 3D ratio would be 1.5 cubed. 1.5 cubed. And see if that gives you the volume of the big one if you do it, if it gives you this number. So try that out.